Hi, this is Hemant. In this video, I'm going to solve question number 6 of MAT 104 NTOM examination. So let's start working on it. Have a look at the question first. Consider the ODE y double dash plus 16y is equal to 4 into delta of t minus 3 pi. And the initial conditions are given as y of 0 is 0 and y dash of 0 is also 0. We were asked to find what kind of real life phenomena is captured by this delta function in this ODE. If this ODE represent a mass spring system, and without solving just by intuition, sketch the graph of the solution. So just by looking at this equation, we should be what will be the graph that immediately strikes to our mind. That's what we were asked to draw, and solve the ODE and sketch the graph of the solution, compare them. So we have to solve this second order differential equation. So let's start with this first part now. What kind of real life phenomena is captured by this delta function? So let's assume a mass spring system of this kind. This is a spring and this is mass of mass m. So if we as we know, if we write an equation of forces acting on this mass, we can write it as ma plus kx plus bv plus is equal to f, the external force acting on it. So if we compare if we just look at these two equations, so this is almost like this one only, with where the this part is 0 and this is ma, y double dash represent ma, and kx is 16y, and this f naught, this external force, this could be any this could be a variable force or a constant force, or this could be of any type. So this function of force is this one. By just comparing, we can judge that. So let me tell about what a delta function represents. So I'm writing the definition here. Delta of t minus a is equal to 0 at x is not equal to a, and infinite at x equal to a. So let me draw this graph of this delta function. Let's draw the axis. So if we consider a point a, so throughout this number line, the value of this function will be 0, except at this particular point it reaches infinite. We just represent this graph as like this, because it's too thin, it is very thin. It suddenly reaches infinity and suddenly drops to 0 at just point a, such that its area under this graph is 1. So that's what delta function represent. So this is the definition of that function. So if we let's assume at t equal to 0, we have this system at equilibrium position, at rest position. So, later, after time t equal to 3 pi, see this is what here t minus 3 pi represent that in my view. See, at time t equal to 3 pi, there is a sudden tap in this acted on this mass, a sudden tap at particular instant time t equal to 3 pi. Due to that tap, a sudden tap that lasts for a very small interval of time, maybe you can say it as impulse, but t is at that, and the width of that time interval is too small, so we can, so it's a very sudden impulse, we can say, at time t equal to 3 pi, due to which this mass is said to be in motion, a vibratory motion. So that's what in my view this delta function represent in real life phenomena. So that's what I feel. So so that's it for the first part. Let's have a look at the second part. Without solving, just by intuition, sketch the graph of the solution. As this is a second order differential equation, you know, the solution will be of form c1 cos bt plus c2 cos some sine something mixture of the sine and cos, or and a few constants. Let me try to draw a graph which between y, the position of that mass, and time t. So at the beginning time t equal to 0, there isn't any motion till time t equal to 3 pi. So at this point this block started its vibratory motion. This could start from anywhere. Maybe initial velocity itself could be, initial position should be here. It should start from y equal to 0 itself. So it should start from here, and some sinusoidal wave or any wave, because it gives a to and fro motion, right? So this could be of this form, or this could be of this form, or something like this, because it experiences a to and fro motion. So this is what I am thinking. This is how the graph looks, what in my view. So let's start the C part now. Here, y double dash plus 16y is equal to 4 into delta of t minus 3 pi. This is a given equation. So I'm applying Laplace here. So let me write Laplace of y double dash, which is equal to s square into Laplace of y, s square into Laplace of y minus s into y of 0 minus y dash of 0. This is Laplace of y double dash, and Laplace of delta of t minus a of a delta function is e to the power minus as. So I'm going to substitute these two equations here. It will give me s square of Laplace of y can be, I'm going to represent it as a capital Y. So I forgot to tell one more thing. This is same for this. So this result is same for Laplace of a unit step function also, which is t minus a, u of t minus a. This is unit step function. I am representing it like in this way. So okay, s square into Laplace of y minus, we were given in the question itself that y of 0 equal to 0 and y dash of 0 is also equal to 0. So s square of y minus 0 anyhow plus 16 into Laplace of y. So 16 into capital Y is equal to I'm going to substitute here Laplace of del of t minus 3 pi. So that will give me e to the power minus 3 pi s into 4, this 4, just multiplying it. So Laplace of y will be, by taking, will be 4 into e to the power minus 3 pi s by s square plus 16. Let me write the one standard form of Laplacian. Laplace of sine at is equal to a by s square plus a square. This is a standard form of Laplace function. So if we observe here in this part of Laplace of y, so it looks something like this, a by s square plus a square. Let me tell one more result of Laplace also. One more result also. E to the power minus as into Laplace of f of t is equal to Laplace of f of t minus a into unit step function of t minus a. This is a result of Laplace functions. So I'm going to use this form here. So I'm going to apply Laplace inverse here. So that will give me y. Laplace y, anyhow it represents Laplace of y. So Laplace inverse will give me only y. And here see, if we see this, it is like s square plus 4 square into e to the power minus 3 pi s. So if we observe this, so this is like Laplace of sine 4t, and e to the power minus as this one, e to the power minus as t minus a. So that will give me a sine of 4 into t minus 4. So as a is equal to 4 here, and unit function is unit function of t minus 3 pi. Here no, I made some wrong here. Maybe just I might have represented this in some other constant type. So these two a are same and this a is different. This a is this a represent this part and this a is representing this. So here a represents 3 pi. So don't get confused there. I might have used different constants. 4 into t minus 3 pi. So that will give me sine of 4t minus 12 pi into unit function of t minus 3 pi. So this is a function. So if we let me draw the graph here. So this is unit step function. So let me define what is a unit step function u of t minus a. U of t minus a is 1 when x is less than a. 0 when x is less than a, and 1 when x is greater than a. This is greater than or equal to a. So this is a definition for a unit step function. So if we substitute this here, so we can solve it further also. It will be sine of 4t, like this will, from basic trigonometric conversions, you can write it as sine 4t into u of t minus 3 pi, unit step function. This is just unit step function. So if let's consider a time which is before time t equal to 3 pi, that will give 0 for this step function, and so 0 into something will give me 0. So till time t equal to 3 pi there won't be any graph, like it will be 0, and later after time t is equal to 3 pi, so it will become 1 and it will be just a sine 4t graph, just sinusoidal wave, sine 4t graph. This is the time axis and this is the position axis. So this is how a graph of the solution of this solution looks like. See, this is much closer to what we expected in the beginning. So see if these two are similar. So this is what we have expected. So that's it. Hope you understand my explanation. Thanks for watching.